Hi everyone, this is Group 93 and this is our project proposal. To give a brief introduction, we're focusing on lung auscultation, which is a process that requires the listening of breathing sounds and is used by clinicians to diagnose a series of lung pathologies such as pneumonia. However, this is a lot of subjective decisions are involved in this process, as you can see in the image on the right side. The introduction of electronic auscultations enables intelligent listening models to aid clinicians in these diagnostics. What we want to do is we hope to create a sound classification model to standardize lung auscultation by improving the sensitivity and specificity. The first method we hope to use is the k-nearest neighbors method. We will start by extracting common acoustic features from the audio recordings and representing these recordings as feature vector based on extracted features. By normalizing and scaling the features, we would ensure that each feature contributes equally to distance computation in the model. As you see on the right side, the KNN model prioritizes local similarity since it only considers the k nearest neighbors. By training the KNN model, we would incorporate feature vectors and the types of cough. The model would then be able to classify new audio based on the majority class of k nearest neighbors. The second method we're focusing on is the support vector machine method, which is unsupervised. The first two steps are the exact same, however, the SVM method has a key difference because it takes into account the overall structure of the dataset and focuses more on the global relationships present. We would also use cross-vitalization to tune the SVM parameters, and we would train the SVM model with pre-processed feature vectors and the corresponding type of cuff. Lastly, with this model, we would like to find the best fit for data by experimenting with a myriad of kernels such as the linear or the radial basis function. To get in our conclusion, what we would like to do after taking all this into account is assign an F1 score for both of these models' efficacy. An F1 score is very optimal because it balances precision and recall, making critical for the imbalance cases. As you can see on the right side, that is the formula. It is especially optimal when one classification outweighs the others and when there's separate costs for false positives and false negatives. When we get this F1 score, we can compare the Canon SVM's F1 score, which would help us determine the most effective method for the classification task ahead of us. Thank you.